Hi everyone, welcome to the video. Today we are going to solve insert and search in a trie. So trie, as we all know, is a data structure that stores words in a tree-like structure. In a tree-like structure where each node represents a character, letter, and path from root to node represents a word. Okay, so here we have to implement two functions, which is insert and search. Okay, so let's say there's a list of these number of words and number of words, and we have a key where we need to find whether this key is present in this list or not. Using this, just we can return it. So in example one, the is present in the list. Okay, one of the letters, and hence we return one. We don't have to return one. The inbuilt function, the no, the code judge will do the work. We just need to insert it and search it. So we will implement it. And second example, see geeks is not present in any of the list. Okay, hence it is not present and zero is the output. But how do we reach here? How do we reach here? So first of all, I will create an insert function. I will create an insert function. So first of all, for k in key. So one thing we know for sure is we have to do something from key. Key is there. Okay, key is there. Key, and we also know that in try this key, let's say the will not be like a single word. It will be in three nodes: T, H, and E. T being the root, its subnode, its down, its child being H, and its child being E. So it will be represented in that format. Hence, we'll need, and also see the children is given as none into 26, and 26 is the character. So this should ring in a bell, even if you are completely new to try also. Okay. So for key in range, we'll create an index. We'll create an index which will hold what? Which will map, will be index of this particular letter of the given key. Particular letter of the given key. Okay. So how do we achieve it? We achieve it using this. So here we are mapping each character, each letter node of a key with its index value, such as if we have 1 as a node, it will be mapped to 0. Then it's if it's b, then it will be 1, and it's c, it will be 3, d 4, so d 3 similarly. Okay, so we mapped all the characters, alphabetical characters, which are the node of this try, to their individual, to their given index. Okay, now we will check if, what is this checking? It is checking if the current node root, if the current node root has a child corresponding to the index given IND which we calculated. So this checks if the current node, which is the root over here, has particular child which corresponds to the index IND. If that's not the case, then create it. If that's not the case, then create it in this index. And, and we all know we have try node. We have try node, so we will use that. We will leverage that. Okay. Okay. After checking and creating a child node, we will now move to the child node. If there is a child node, if there was not a child node, create it. But if it is well and good, we will move to that child node. It's root will become what? Root will become the child of this child node, child of this root node, which is index. So after ensuring that child node exists, now we moved on to the root pointer. We moved the root pointer to the child node which is available. Okay, so this way our algorithm will continue to traverse down the trie based on characters in the key. Characters in the key. Okay, okay. At the end, very important thing. We'll need there's a flag. There's a flag if it represents that end of the word has been reached. This represents that end of the word has been reached. How? This will help us more when we are in search operation. So what it does is once all the characters in the given key has been processed, okay, has been traversed, it will mark the current node root as end of the word. So this will typically flag. So typically flagged that to indicate that a represented string by the trie has been fully inserted. Okay, so here we inserted our key. Okay, inserted. Now we need to check whether the given key is available or not. Whether the given key is available or not. Okay, now the search operation. So first of all, again for k in key, okay, we will traverse for all the characters nodes in a given key, which we need to check whether it is present in the trie or not. Now we will calculate its index as we did earlier. And we will calculate its index by mapping it to the corresponding index value. Okay. Now for each character here, for each character k, this line will calculate an index ind using the difference between Unicode of k and Unicode of character a. Okay. So let's say we have character okay b, then k has b. Okay. So then in that case, what will be the order of k? It will be 98, and order of character A is what, 97. So this will yield us 1, and that is what I told earlier when I was doing the insert function. As I told that A will point to 0, B will point to 1, C will point to 2, and D will point to 3, and so forth. Okay. Now after that, okay, now that we have our index, we'll check the child nodes. We will check the child nodes. This will check if the current node, which is the root, has a child node corresponding to index ind. Okay, if it has no child, if there's no child at that particular index ind, this means that the character k is not found. Character k itself is not found. Let's say you are finding boy, and if b is not there, then how can you find, how can there be a boy? Because boy starts from b. Or let's say there's o. Okay, o is not there at a point. So boy consists of three characters b, o, y, and if o is not there, then boy will not be there. Okay, this is, it means implicitly. Okay, now if there was no child node, then we return false. But if there is a child node, we will move forward towards it. If there is a child node, we will move forward towards it. Okay, now after confirming that the child node exists, now we are moving the root pointer to that child node. Okay, now this will allow our algorithm to continue traverse down where, traverse down the given trie based on the characters in the key. Okay, at the end, now after we have traversed all of the key characters, will return root dot is end of word. As I told you earlier that this flag will help us in the search operation. Now, once all the characters in the key have been processed and the traversal reach the last character, okay. Now this will check if the current node, which is root, represent the end of word or not. If this flag is true, which was the case, we did an insert, okay. But it need not be necessary. It need not be necessary. Let's say these are the characters, and we are checking boy, but there's no boy. Okay, there's no word of boy. In that case, it will be marked as false. Okay, we have not inserted, so this particular word boy will be marked as false. There will be nothing like boy. Okay, okay. If it is true, if root dot isn't of work is true, this means that entire key has been found in the trie, so it will return true. Otherwise, if it was marked false, isn't of word flag was marked as false, this will indicate that the key is not present altogether. Okay, so as we have implemented our search function and insert function, let us submit it and check the accuracy. And yeah, as you can see, it did the job. It does the job in pretty amazing time format, and it does very easily. So see, the function is quite easy to implement, quite simple. But there is concept tries not talked about more. Hence, I have made this video very long and explained each word very in easier manner, in easier language. So I hope you enjoyed it. I would have made the code concise, but in order to make you able to understand better from in a better way, I made it long and spread it. So I hope you enjoyed it. Thank you. Have a nice day.